Okay, so today, before we begin, I suppose it's time to refresh ourselves on the equation of a line. So we know that equations of the line are generally written in the form ax plus by plus c equal to 0, or we also have the other form where it's written in terms of the slope, y equals mx plus c, or it gives us, I suppose, an easy picture of what the slope is and where it crosses the y-axis. Okay, so that's two things that we've generally been used to for the equation of the line. So similarly, but I suppose really what are these things? They help to identify the line. And in the same way, we want to be able to identify circles. Um, so when we've been dealing with lines, we've also, just as we noted here, the slope has been an important thing. We know from the past that in dealing with a circle, a radius is obviously one of the key things. So here we're going to use this information, or hopefully by forming equations of a circle, it will help us to find out more information about the circle, such as its radius length, in the same way that these helped us to find out more information about the line. So that's where we're going to start today. Off we go. Okay, so here we have a circle. We are told that its center is h comma k. We have its radius here, and there's a point on the circle, and that point is x, y. So we can see our x value here and our y value there. So x, y is on the circle. So if we want to find the equation of this circle, well, let's see what we can do to find more about r. So if I want to see what r is, well, we know from our distance formula that distance is equal to, so distance is equal to x2, the square root of x2 minus x1 to be squared, plus y2 minus y1. So we've got 2 points. We've got h comma k, the center of our circle. So I'm going to call that x1, y1. And we also know that another point on that radius line is xy. In fact, this is the length that we're trying to find, the length of the radius. So here, x2, y2. So that's equal to our radius r. So we can say r is equal to, well, x2, which is x in this case, the square root of x, minus h, all to be squared, plus, and y2 in this case is y, and that's also minus y1, which is k in this case, and that's again all to be squared. So if we square both sides to get rid of our square root sign, we get r squared is equal to x minus h, all to be squared, plus y minus k, all to be squared. And so that formula there is our equation of a circle formula. So that's the very basic formula we have for finding the equation of a circle. So let's look, for example, what would happen if we had a center 0, 0. Well, this would be h, and this would be k. So r squared in this case is equal to, well, x minus 0 to be squared, plus y minus, and k is also 0 in this case, all to be squared. So, and that's r squared. So r squared is equal to x squared plus y squared. Okay, so that's another important formula we're going to use. This formula here, our general formula for the equation of a circle, is in our log tables. This is not, but we can clearly see by substituting in 0, 0 for h and k, that's where we get this from. Okay, so here, it's so important, and it's our equation of a circle formula. Okay, so let's make sure we get both of those cases written down in our maths copy. Okay, so looking again at this one, so this is the case where we have the center of the circle equal to 0, 0. So the center of this circle here is the origin. So obviously if I see an equation that looks of this form, straight away I know I can find the radius length. So for example, if I have a circle and we're told it's x squared plus y squared is equal to 25, well then I know, well sure, r squared is equal to 25, so or the radius has to be the square root of 25, which is 5. Okay, so straight away from looking at equations of this form, are we able to see what the radius is of that circle? Okay, so for example, we'll just do another one, so it might be a question something like this. Okay, so here we're asked to find the radius length of the following circle where x squared plus y squared is equal to 169. So straight away I know from my formula here, x squared plus y squared is equal to r squared. So I have r squared is equal to 169. So r must be the square root of that, which is 13. The other thing, again, of course, I know from looking at this circle is its center is equal to 0, 0. Okay, so the center of the circle is the origin. Okay, we'll look at another type of question in relation to this. Okay, so here we have another type of question in relation to the equation of a circle. So it says, find the equation of the circle that has center 0, 0 and that touches this line here at one point only. Well, if the circle touches a line at one point only, that means that it is a tangent line. It's a tangent to the circle. Okay. Now we have a formula to get the perpendicular distance from a line to a point. And we know that the perpendicular distance from a line to a point is the shortest distance. It's the radius line. So very important for us to remind ourselves of that as well. So the perpendicular distance from the center of a circle to a tangent is equal to the radius length of the circle. So that means that we can use the following formula in relation to it. And that formula again is in your log tables on page 19. Okay, so we have our formula from our log tables. We know that this is going to give us the radius. So off we go. So here we have our point 0, 0. So that's going to be x1, y1. We also have our equation of our line, 2x minus 3y minus 6 equal to 0. And for this formula to work, it has to be in this format. Okay, so here we have A, B, and C. B again with its sign and C also with its sign. Okay, so we have our radius is going to be equal to, so r is equal to here 2 times 0 plus minus 3 also times 0 minus 6, and that's our absolute value here, all over the square root of a squared, which is 2 squared plus minus 3 to be squared. Okay, and so that's going to give us r is equal to minus 6, absolute value, over the square root of 13. And so then just to make this positive or to tidy it up, so we're taking the positive value obviously as well, because we know a distance, a length can never be negative. So here we're going to have 6 over the square root of 13. So that's our radius. Okay, so now that we have our radius, we can set it aside over here. The next thing, all we want to do now is to find the equation of the circle. So writing down our circle formula. Okay, so here we have our circle formula. So x minus h all to be squared plus y minus k all to be squared is equal to r squared. And so we know here, well, our center is 0, 0. So here we have 0, 0 as our center. So that's h, and this is k. And so now we have x minus 0 all to be squared plus y minus, again, 0 all to be squared. In fact, we know we could leave out that bit and just have x squared plus y squared is equal to r squared. So that's going to be 6 over root 13 all to be squared. So it's going to give us an equation for this circle, x squared plus y squared, well, 6 squared is 36, over root 13 squared, which is 13, and that is our equation for the circle. Now, if we could tidy that up and we could just have on the bottom here, or multiplying across 13x squared plus 13y squared is equal to 36. Okay, so either of those formats at the end are perfect for our equation for the circle. Okay, so here we're asked to find the equation of the circle which has a diameter with the following endpoints. So the first thing we're going to do is obviously write down our formula for the equation of the circle. Okay, so we know with this formula that we need to have a center which is h comma k, and we need to obviously know the radius. So what could we do here? We know the two endpoints, so we could find here to find the center of the circle. If that's the endpoints of the diameter, well then we could use just our midpoint formula. Okay, so there we have our midpoint formula. So let's get started, and at least that will give us our center of our circle. So we've minus 4 minus 6, 6 comma 4. Let's label our points, x1, y1, x2, y2. And so our midpoint, or our center, is going to be equal to, we'll just call it midpoint, is equal to minus 4 plus 6 divided by 2, comma, minus 6 plus 4 divided by 2. So our midpoint then is 1 comma minus 1, because minus 4 plus 6 is 2 divided by 2 is 1. And likewise here, minus 6 plus 4 is minus 2 divided by 2 is minus 1. And so that is equal to our center. So that's the first bit. Now we need to work out, well, what else? So we have our center, so we can fill in h and k. Next thing we need to work out is our radius. So again, using our distance formula, and this is one of the things we're going to see in working with circles, that we're using a lot of the same formulas that we have from using from the line from the same topic. Okay, so here we have our distance formula again, which is d is equal to the square root of x2 minus x1 all to be squared plus y2 minus y1 all to be squared. Okay, and so we want to fill in, 1 is the distance. Obviously we could get the length of our diameter and half it, otherwise we can just use our center point, which is 1 comma minus 1, and either of the points, so we might go to the point 6, 4 and label them again, x1, y1, x2, y2, and that is going to give us then a distance of d is equal to, so 6 minus 1 all to be squared plus y2 is 4 minus minus 1 all to be squared, and it's the square root of all of that. So d is equal to, so that's 5 squared plus 4 plus 1, so that's again 5 squared. So 5 squared plus 5 squared is 25. So our distance is equal to the square root of 50. So that's our radius. Okay, so now we have a center and we have a radius, so we can sub straight into our formula for our equation of the circle. So our center, rewriting them again, is 1 comma minus 1, and we're going to label that h and that k, and our radius is equal to the square root of 50. Again, leaving it at that because we're going to be squaring it in a minute anyway. Okay, so all we have to do now is sub in, so our equation is going to be x minus, well, h is 1, oops, sorry, 1 all to be squared plus y minus, and here k is minus 1 all to be squared is equal to root 50, and again that is to be squared. So we'll straight away, that square root and square sign can cancel out, and we have x minus 1 squared plus y minus by minus is plus 1 all to be squared is equal to 50. And that's the equation of our circle. We can leave it in that format unless they specify that they want it expanded out. And just one point of note here, really important. What do we see here? Well, our center was 1 and minus 1. The signs are opposite here. Okay, so again, you can see it very clearly in the formula up here. We've x minus h, but the center is h, y minus k, and the center is k. So actually, we'll just one last look at a couple of questions here as well, some simpler ones. Okay, so here we are asked to find the center and radius of the following circles where we've been given the equation of the circle. So starting off with number 1 there, so we have x minus 5 all to be squared plus y plus 3 all to be squared is equal to 25. Now if we rewrite our equation of a circle formula, so well, from this I know that minus h is going to be equal to minus 5, so h is equal to 5, and here I know that minus k is equal to 3, so k will be equal to minus 3. So the center of this circle, the center is equal to 5 comma minus 3. So again, what do we notice here? The opposite signs. Okay, and then our radius, very straightforward, or squared is equal to 25, so the radius is equal to 5. So that's our answer to the first one. Okay, and question 2, we are given the equation x plus 2 all to be squared plus y squared is equal to 11. So here, well, I know minus h is equal to 2. So that means h will be equal to minus 2. Here I'm going to have minus k is equal to, well, there's nothing here to added or taken away from k, so I know it must be 0. So likewise then k is equal to 0. And so the center of this circle will be minus 2 comma 0, and also then we have our radius squared, or squared is equal to 11, so our radius is equal to the square root of 11. Okay, so let's make sure that we get all these notes down into our copy, and then we can do some questions from Schoology. Okay, thank you.